All right, ready to jump into the world of cancer immunotherapy.
Sounds good to me.
We're looking at CD155 today. It's a protein,
Yeah.
but it's pretty unique. It has like this dual nature to it.
Right.
It can help our body heal, but it can also help tumors avoid our immune system.
Yeah, it's a lot like a double agent.
Huh.
CD155, also called PVR, which stands for poliovirus receptor.
Oh, okay.
It's really important for normal cell function.
Okay.
So it helps cells stick together and repair tissues. But in cancer cells, well, it can get kind of hijacked.
Oh, so it's like it's giving the tumors a disguise.
Kind of like it lets them evade the immune system.
That's pretty sneaky. So we're going to be looking at this article from Assay Genie today,
Mm-hmm.
and it's talking about how scientists are trying to block CD155 from doing that.
Right.
So how does CD155 actually work?
Well, it binds to different receptors on immune cells. Think of it like it's sending signals.
Yeah.
But these signals can be kind of contradictory, you know?
Uh.
Sometimes they tell the immune cells to attack, and sometimes they say, stand down.
So it can actually tell our immune system to ignore a tumor.
Pretty much, yeah.
Wow, that's wild. Can you explain a little more about how that actually works?
So let's imagine for a second that our immune system is like an army. We've got NK cells and T cells.
Okay.
They're like the elite special forces.
Right.
They're trained to target and destroy those tumor cells, right?
Mm-hmm.
But CD155 can mess with their orders.
Oh, how?
It binds to something called TIGIT.
Puget.
Yeah, it's a receptor, and you can think of TIGIT as an inhibitor, like a stop sign for the immune system.
Okay.
So when CD155 binds to TIGIT, it basically suppresses the immune response.
So it's preventing those NK and T cells from attacking.
Exactly.
So is there anything that can counteract that? Like, are there any good guys on the battlefield?
There is, actually.
Oh, okay.
There's another receptor called DNM-1, and it does the opposite of TIGIT.
Okay.
So when CD155 binds to DNM-1, it boosts the immune response.
So it actually encourages those NK and T cells.
Yeah, exactly.
So it's like this constant push and pull between TIGIT and DNM1.
Right.
And CD155 is right there in the middle, kind of deciding which signal gets through. But how does high CD155 actually lead to a worse outcome?
Well, when there's a lot of CD155, it can allow tumors to grow without being detected,
Okay.
because the interaction between CD155 and TIGIT really weakens the immune system's ability to fight back.
So more CD155 means more TIGIT activation, weaker immune response.
Yeah.
Didn't the Assay Genie article talk about some ways that scientists are trying to fight this?
Yes. They've developed a monoclonal antibody called SKI.4.
CUI.4.
Uh-huh. And it's designed to block that interaction between CD155 and TIGIT.
Really?
Yeah.
How does it work?
Well, it binds to CD155,
Okay.
and that prevents TIGIT from attaching.
So it's basically removing the stop sign for the immune system.
You got it.
So those NK and T cells can do their job.
Exactly.
That's pretty cool.
It is.
So is that used on its own, or are there other things that it's used with?
Well, researchers are looking at using it with other therapies.
Yeah.
Like anti-T1, it's another type of immunotherapy. It also targets those immune checkpoints.
Oh, interesting. So it's like a tag team approach.
Ah, yeah, you could say that.
That's really incredible.
It is, and there's actually even more research happening now. They're looking at CD155's role in blood cancers, too.
Wow, so not just solid tumors anymore.
Nope.
Like leukemia and lymphoma.
Exactly.
That's fascinating. What else is really interesting about this research?
Well, for me, it's just how complex the immune system is, you know, and how CD155 interacts with all these different cells.
Yeah, it's pretty amazing.
It really is.
We've covered a lot about CD155, so I think it's safe to say that it's a pretty big player in the fight against cancer.
Oh, absolutely.
Before we move on to part 2, though, what are some of the key takeaways for you so far?
For me, it's just how intricate the whole immune system is. And all these molecules and cells are constantly interacting, and we're really just starting to understand how it all works.
Right. It's wild. I'm especially fascinated by how we can use our own immune systems to fight disease. It's like this hidden superpower we have.
It really is.
But we're still just scratching the surface of what CD155 can do and its role in all of this.
Yep.
Be sure to join us for part 2 of our deep dive, where we'll get into the challenges and future directions of all this.
Sounds good.
See you there.
It really is amazing how far immunotherapy has come.
Yeah.
Like just in a few decades, it's gone from this fringe idea
Right.
to being this huge force in cancer treatment.
Yeah, it's true. It really is.
It's remarkable.
It is,
Yeah.
but with any revolutionary treatment,
Yeah.
there are going to be challenges.
Yeah.
So what are some of the hurdles that come up when you're
Right.
talking about these CD155 targeted therapies?
One of the biggest ones is
Yeah.
something called immune-related adverse events,
Okay.
or IRAEs.
IRAEs, what
Yeah.
are those?
Basically, there's side effects
Okay.
that can happen when the immune system gets a little too overactive.
So the immune system's kind of going into overdrive,
Yeah.
and it's attacking healthy cells along with the cancer cells.
Right, exactly. And they can be
Okay.
pretty mild, like fever,
Really?
fatigue,
Mm-hmm.
but they can be more serious too.
Oh, like what?
Well, one example is something called cytokine release syndrome.
Cytokine release syndrome.
Yeah.
Okay.
It's when the immune system releases all these inflammatory molecules,
Mm-hmm.
and that can damage organs.
So it's kind of this balancing act.
It is.
You want to boost the immune system enough to fight the cancer, but you don't want it to
Right.
attack the body itself.
Yeah, exactly.
That's a tough one.
It is. And researchers are constantly working on this,
Okay.
trying to refine those therapies, make them as safe and effective as possible.
Right.
That includes, like, figuring out the best doses and timing for treatments and everything.
So it's a lot of trial and error.
It is, yeah.
Huh. And what about the tumors themselves?
Oh, yeah.
Can they develop any resistance to these therapies?
Oh, absolutely.
Really?
Tumors are
Yeah.
incredibly adaptable. You know, they can sometimes reduce the amount of CD155 they make,
Huh.
so they're less vulnerable to, like, SKI.4,
Right.
or they might activate other immune checkpoints,
Wow.
you know, find new ways to suppress the immune system.
So it's like this constant back and forth.
I do, yeah.
Like an arms race
Kind of. Yeah.
between the scientists and the tumors.
The scientists are always working on something new, you know.
Right.
One strategy is to target
Yeah.
multiple checkpoints at the same time.
Okay.
That makes it harder for the tumor to escape.
That makes sense.
And another is to try and
Mm.
engage other immune cells,
Okay.
like macrophages
Mm-hmm.
and dendritic cells.
All right. So more of a
Right.
coordinated attack.
Exactly. It's all about outmaneuvering that tumor.
Right.
Give the immune system the best chance it can get.
So where do you see this field going in the next, 5 to 10 years?
You know, I think we're moving towards
Yeah.
personalized medicine.
Personalized medicine. So instead of this one-size-fits-all approach,
Right.
it's more targeted.
Exactly.
Okay.
Scientists are using biomarkers now to figure out which patients are most likely to actually benefit from certain therapies.
So it's more tailored to the individual.
Right. Yeah.
That's amazing.
It is.
It seems like we're on the verge of a major shift
I think so.
in how we treat cancer.
Yeah.
What other advancements are you really excited about?
Well, one thing that I think is really cool is the potential for preventative immunotherapy.
Preventative immunotherapy. So instead of just treating cancer, you're trying to prevent it in the first place.
Exactly.
Wow, that would be incredible.
It would.
How would that even work?
Well, you know, we could identify people who are at high risk
Okay.
for certain cancers
Yeah.
and then intervene early
Okay.
with immunotherapy.
Interesting.
So you could stop the tumors before they really take hold.
Wow. So you're shifting the focus from reaction to prevention?
Yeah, exactly.
That's amazing. That could save so many lives.
It could. It's a bold goal,
Mm-hmm.
but I think it's achievable, you know?
Yeah.
The pace of research is amazing,
It is.
and I'm sure we'll see more breakthroughs in the years to come.
It's really inspiring to think about all the possibilities. And it seems like CD155 is playing a key role in all of this.
It is.
But are there any other potential uses for these therapies?
Oh, yeah, definitely.
On cancer.
We're discovering more and more about the immune system,
You're right.
and new roles for CD155 are coming up all the time.
Oh, interesting. So it's not just about cancer anymore.
Right.
What other conditions?
Well, there's some research that suggests that CD155 could be involved in autoimmune diseases.
Yeah. Autoimmune diseases.
Yeah, so
Okay.
that's when the immune system attacks the body's own tissues.
Right.
And there's even some evidence
Yeah.
that it might play a role in infectious diseases too.
Wow. So potentially a whole range of illnesses,
Exactly.
from autoimmune disorders to infections.
Yeah.
Huh. That's incredible.
It's a fascinating area.
It is.
We might one day be able to
Yeah.
modulate that immune response using CD155
Right.
in a way that helps a lot of different patients.
That's a revolutionary concept.
It is.
It seems like we're only just beginning to tap into
Yeah.
all the potential of CD155
Mm,
and what it means for all these different therapies.
we are. And the more we learn,
Yeah.
the more opportunities we'll have to develop really groundbreaking therapies.
This has been an incredible exploration
It
of
has.
CD155 and its impact on all these different therapies.
Mm.
We've learned about the challenges,
Right.
the exciting potential.
Hmm.
As we wrap up this part, what are some final thoughts that you want to leave with our listeners?
What really strikes me is
Mm.
just how much progress we've made
Hmm.
in just a few years.
Right.
Like, we've gone from this limited understanding
Hmm.
to developing these therapies that can actually harness the immune system
Right.
to fight disease.
It really is mind-blowing.
It is.
We're essentially learning to speak the language of the immune system.
We are.
It's amazing.
Yeah.
It's a testament to all these brilliant scientists and researchers
Mhm.
who are just dedicated to pushing the boundaries and improving human health.
Well said.
And as we continue to explore these intricate workings,
Yeah,
I'm confident we'll see even more amazing breakthroughs.
I think so too.
This has been an inspiring conversation.
It has.
I'm excited to hear what else you have to share in part 3
Sounds good.
of our deep dive, where we'll
Yeah.
continue our exploration
Okay.
of CD155 and its impact on the world of medicine. Welcome back. For this last part of our deep dive, let's talk about what all this means for the future.
Well, it's definitely an exciting time to be in this field. I mean, we're seeing a real shift in how we're thinking about treating cancer and maybe even other diseases too.
It's true. We've kind of cracked the code of our immune system.
Yeah, it's incredible.
And now we're just starting to understand all the potential it has.
Right.
But with any powerful new technology, there are always new challenges, right?
Oh, for sure.
What comes to mind for you?
I think the biggest one is accessibility.
Accessibility.
Yeah, these new therapies are really expensive
Oh, right.
to develop and even to administer.
Yeah,
So it raises questions about, who can actually afford them.
that's a good point.
We have to think about equity, and making sure that everyone who needs these treatments can get them.
Absolutely. It shouldn't just be for the wealthy.
Right.
What other areas should we be careful about as this field keeps advancing?
Well, we have to remember we're messing with the immune system.
Yeah.
There could be unintended consequences.
Right.
I mean, these therapies have shown a lot of promise,
Mm-hmm.
but there's always the chance of side effects.
Of course.
We might even see new health challenges.
Oh, wow. So we need to keep a close eye on things.
Exactly. And as we start combining more therapies,
Yeah.
informed consent becomes so important.
Right.
Patients really need to know the benefits and the risks.
So they can make good decisions.
Exactly.
I think it's important to remember that we're still early on in understanding how all this works.
Absolutely.
What do you think people should know when they hear about these amazing breakthroughs?
It's not a magic cure.
Right.
I mean, it's amazing.
Mm-hmm.
It's revolutionized treatment for a lot of people, but
Yeah.
it's not a cure-all.
So we need to be realistic.
I think so. And we can't overhype the benefits.
Good point.
Open communication is so important
Yeah.
for scientists and for the public.
So tempering the excitement with like a healthy dose of realism.
Yeah, pretty much.
This has been an amazing journey exploring CD155 and immunotherapy.
It has.
We've learned so much about how it works, the potential, the challenges. Any last thoughts before we wrap up?
It really makes you realize the power of human ingenuity, doesn't it?
It does.
I mean, we've come such a long way in understanding the immune system.
Mm-hmm.
It's incredible.
It is.
It's all thanks to these brilliant scientists all over the world who are dedicated to this.
It's inspiring, really.
It is.
This has been a truly fascinating look at CD155 and how it's impacting medicine. Thank you for joining us on this deep dive, and keep exploring. We'll be back soon with more deep dives into the world of science and innovation.